Welcome back, everybody. And in our last video, we went over the basics of probability. And in this video, we're going to go over experimental probability. And experimental probability is just finding the probability based off of an experiment that's been conducted. So this is our formula for a given experiment. We can find the experimental probability by putting the number of times the event occurs over the total number of trials. So if I'm going to find the experimental probability, and let's say I want to find out how many times I roll a 2, I roll a dice 100 times, and I get a 2 10 of those times, then my experimental probability is 10 out of 100, or 1/10. It's pretty easy to find. Let's take a look at our first example. It says, Martin has a bag of marbles. He picks a marble at random, records the color, and places the marble back. He repeats the process several times and records his results. Find the probability of drawing each color. So, we want to find the experimental probability of finding each type of color based off of the experiment that he conducted. First thing we need to do is figure out how many times he conducted the experiment. Well, if he drew red 12 times, blue 10 times, green 15 times, and yellow 13 times, we can figure out the total number of trials he had by just adding all of those together. And 12 plus 10 is 22, plus 15 is 37, plus 13 gives us 50 total trials. Whenever we find probability, experimental or theoretical, we put our total number of outcomes in the denominator. Okay, so now all we do for each color, so we'll start with red, is put the number of times he pulled out that color in the numerator and simplify. So if we look at red, 12 times out of 50, he pulled a red one. That means the probability is 12 out of 50, but we can simplify that because 2 goes into both of them, which gives us 6 out of 25. And that cannot be simplified anymore, so our probability of drawing a red is 6 out of 25. Let's take a look at our next one. Our next one is blue, and we do the same thing. We place the number of times we've got a blue, let me change the color, over the total number of trials. So we have 10 blues out of a total of 50 trials. We simplify because 10 goes into both of them, and we say the probability of drawing a blue is 1 out of 5. Next we have yellow, and for yellow there is 13 times we pulled a yellow out of 50 total trials, so our probability is 13 out of 50, which cannot be simplified, so we leave it as 13 out of 50. And last we have green, and we pulled a green marble out 15 times out of 50, and we can simplify that by dividing 5 into each of them. 5 goes into 15 3 times, 5 goes into 50 10 times, so we can say there is a 3 out of 10 chance, or a 30% chance, or a 0.3 chance of pulling a green marble. So now we have this your turn section. Take a second, try it on your own, pause the video, come back when you have an answer, and I will go over how to find it. So it says a spinner has 3 unequal sections, red, yellow, and blue. Unequal meaning like the red side might be larger than the blue side, or the yellow side might be larger than the red side. So the spinner's not equal. Maybe we have one side that's larger than the rest of them. We have a spinner. Maybe instead of being broken up into 3 spaces, it's like this. And this side could be the red side, this one could be the yellow side, this one could be the blue side. Okay, so a spinner is broken into 3 unequal sections. The table shows the results of Nolan's spins. Find the experimental probability of landing on each color and write your answer in simplest form. So first we need our total number of trials. Well, we have 10 red, 14 blue, or 14 yellow, and 6 blue. We add those 3 numbers together and you get 30 trials. For red, we spun red 10 times out of 30. So our probability is 10 out of 30, which we can simplify to 1/3. For yellow, we got 14 out of 30, which we can simplify to 7 out of 15. And for blue, we got 6 out of 30, which we can simplify to 1/5. Okay, so the point of finding experimental probability leads us to our next section on being able to make a prediction based on experimental probability. Our second example says, if a batter in baseball has a .250 batting average, that means they get a hit on 25% of their at-bats. Using this batting average, determine how many hits a batter will get in their next 32 at-bats. So, if we remember, 25% is just our fraction out of 100. So if you get a hit on 25% of your at-bats, that means you get a hit on 25 out of every 100 at-bats, because percent is out of 100. This simplifies down. 25 goes into the numerator and the denominator. So that means they get a hit on 1 out of every 4 at-bats. We can use this knowledge to then predict over the course of a longer period of time how many hits they might get in a certain number of bats by using a proportion. Okay, and I set up my proportion exactly the way I have it now currently. So this person gets 1 hit every 4 at-bats. And in our problem, it wants us to figure out how many hits they would get in 32 at-bats. Okay, so we write our proportion out, we put our at-bats with our at-bats, and this gets a variable. 1 hit every 4 at-bats equals a certain amount of hits over 32 at-bats. Now remember, there's 2 different ways to solve our proportions. We can see that to get from 4 to 32, we just have to multiply by 8. So we multiply 1 by 8, or we cross multiply 32 times 1, and then we divide by our extra number. So we divide 32 divided by 4. Either way, you should be able to see that this person would get 8 hits over 32 at-bats. And this is the important part of experimental probability, because we perform these experiments so that we can see how many would occur in a larger number, or we look at the number of things that have sold in order to predict how many more can be sold over a longer period of time. And the last thing I really want to talk about with experimental probability is just talking about how you can see the connection between decimals, percents, and fractions in probability. So for example, let's just say I have 4 counters. Okay, and 3 of the counters are green, and 1 of the counters is, let's say, blue. Okay, and I put those counters in a hat, and I said, what is the probability of picking a blue counter? Well, the probability of picking a blue counter is 1 out of the 4 counters. We are able to turn this from a fraction to a decimal and to a percent, and they ask you to give your answer in one of these 3 forms. Okay, if we know 1 out of 4 to figure out a percent, we know the percent is out of 100, so we can set up a proportion to figure it out of 100. Okay, and we should know 100 times 1 equals 100, divided by 4 gives me 25%. So 1/4 and 25% say the same thing. We also know that 25% as a decimal should be written as 0.25, but if we didn't, we could take 4 and divide it into 1. Okay, 4 doesn't go into 1, so I put a decimal point. I added my 0 here, and then I divide in. Goes in twice. 2, bring down another 0. Goes in there 5 times. and we get 0.25 as our decimal. So make sure you're able to bring it from decimal to fraction to percent between those three different things, because the answers may be in any one of those three forms. If you have anything you have questions on, make sure you ask me.